it's recording now. Entonces now we have four kinds of transformation. The most important transformation on the basic function. So the first kind of transformation, number one, is vertical shift. Vertical shift. What is that? Well, we have the basic function, okay, we want to call f of x. Remember, this is a function notation, no? Okay, help me to understand much better this. And this is equal y. And the vertical shift is you take the basic function and you adding or subtracting, depending, is y equal now f of x plus a constant. Okay, we want to call a. A is a constant, it's a number. It's a number. Entonces now we have two possibilities, no? We have two possibilities. Suppose. Now I want to show you in Desmos to see super clear this idea. For example, you have the basic function that I assume to understand this as a quadratic function because it's nice. Now quadratic function look like that. It's a parabola. Okay. Now the idea is doing transformation, addition or subtraction, one constant, one number. For example, y equal x squared plus 2. Well, it's easy to understand, no? The action of the transformation is it's the same shape, but you shift 2 units over in that direction, over. Suppose que es negative, y equal x squared minus 3, entonces down, it's down. Suppose it's the curve. Okay, this is x squared minus 3. It's going down because the constant, the number part that we are using is negative, no? The black one is the original x squared. The red one is the vertical shift over is x squared plus 2, no? I put a hypothetical number, no? And the blue is the minus 3 gets down. In conclusion, so you analyze the points, the transformation vertical shift consists, and you have one x comma y point, and somehow you converting to another point que es x comma something, because the x stay the same, because the action that we are doing is addition plus or minus, and the y part, so it's y plus a. And depending the sign of a is positive, I move it up, and a is negative, I move it down. This idea is super clear or super confusing?
Clear.
Clear. And we can generate a family of the function que belong to the same. In this case was a square function. It's a parabola. But we can, in the example, now we are discussing the theoretical part. When you understand the theoretical part, I bring a lot of examples to illustrate very, very well this idea. Okay, let me switch in to Desmos, because in Desmos is fantastic and you can see clear everything. Let me try. Desmos. Okay. Here. Okay, there you go. Switch to another window. Okay, Desmos. Okay, cool. Do you see or not? Do you see?
Yes.
Okay, look. This is the first function that we are studying is the parabola, x squared. I select this because it's easy to understand, no? But in general, we select another function in the example, no? And now I am doing the transformation. You adding plus something, and this plus something I put in blue color. I'm moving, when I'm moving this slider, for example, when it's positive, upward, and when it's negative, down. Super clear? Super clear?
Yes.
Can you repeat, please?
Absolutely. What part do you want to repeat?
The second one, the
When the A is positive, it's obvious that you're adding something in the y component. Therefore, the curve is the same shape, but moving over, positive, over. And when you put negative, subtraction, moving downward. Subtraction what? Subtraction the y part. The x part stays the same. Cool?
yes, thank you.
Okay, let me take advantage that we are in Desmos now. We discussing the four transformation. I want to discuss in the four transformation geometrically to see the effect. Somebody making noise, huh? Who making noise? Okay, cool. Okay, entonces now. Okay. Let's doing the second transformation. The second transformation, after I promise, okay, I want to write everything in the whiteboard. But take advantage that we have now in Desmos and you see the effect. And so you have some questions, you let me know, I explain in the whiteboard clear, more clear. But suppose now that you are adding or subtracting the same number A, but no outside the parenthesis like that. No, inside the parenthesis. What is the effect? Well, in my opinion, the effect is similar, it's a shift. But the problem is that you adding or subtracting inside the parenthesis, therefore the motion is not vertical, it's horizontal. Entonces, ¿en what direction? Because it's a little bit confusing. Look, this and that color is the new function. Remember, in red color is the basic original. When you move into the positive direction, so when you move into the positive value, sorry, wow, the parabola is moving to the left. What is the reason que es completely opposite? Because the operation inside the parenthesis, is reflecting like inverse operation. Si es plus, es left. And si es minus, es right. Do you see that? At least the effect. Do you see or no?
Yes.
Cool. Okay, now remember to say now, wow, I don't understand very well because it's opposite to the common sense. But no. Because you need to know that the operation inside the parenthesis, when you are doing something inside, it's reflecting like a receipt, like an inverse. Okay, now suppose multiplication. Now I have a function, f of x, and you multiply by a constant a, multiply, no addition, no subtraction, multiplication by a factor, a multiplier, a. So now in this case, obviously, we are doing the deformation of the curve. Okay, it's like a stretch or compressing, depende, no? Compress, it's not shift. Shift is motion. Shift is stay the same shape, but moving the position. This is shift. Vertical, when you adding or subtracting outside the parenthesis, horizontal when you're adding or subtracting outside the parenthesis. And this is multiplication. This is multiplication. Look, take a look. The effect. Okay, we have one parabola, original basic parabola in red color. Now we have a new transformation in black color, que es, you know, it's the same parabola, but it's narrow. Okay, and the effect, the name of this effect is a vertical stretch. Vertical stretch. When you multiply, in this case, you multiply by 10. Wow, this is same parabola, but multiplication. No, not by 10, no, by 7.7, sorry. However, if you multiply by a number less than 1, suppose 0.5, 0.6, 0.8, look at the effect. The effect is the my new parabola after the transformation is wider, and the name of this is vertical compress. Vertical compress. Maybe you are not totally agree with the name, but the idea behind this is compressed because the guy que give this name, suppose que somebody push down the parabola, okay, entonces now it's compressed. It's compressed. This is a stretch, look, and this is compressed. Oh, no, it's compressed. However, si the factor is negative, so we have, so now my parabola now, open down, is reflection. Bueno, actually, it's not pure reflection, it's the reflection, and also, okay, si es pure reflection is when there's -1. When there's -1, when the factor is -1, so the y value is negative value, and the x stays the same. Now it's a pure reflection with respect the x-axis. So the x-axis behave like a mirror, and the new curve, que is the black one, is the image of the red one. Okay. Entonces we have, when you multiply, we have three kinds, no? Stretch, compressed, and reflection. Reflection is when they change the sign. Okay, now let me try another transformation, guys. Pero I change the function because in the parabola you don't see very well this effect. Let me show you. Suppose now I select in the library of the function that we have. You select the square root. Oh, look at that square root function. And the square root function, you know, domain is also positive number, negative number no, it's out of the domain. But I want to transform it multiplication by the factor, but no outside the parenthesis, you know, inside the parenthesis. The effect is completely opposite. When you multiply out inside the parenthesis, the effect is that the x component is divided by this factor. Okay? Remember, any operation inside the parenthesis, the effect you see is completely reciprocal. Completely reciprocal, no, or opposite. So you addition is subtraction. So you multiply is division. Division what? Division the x part. Let me show you. Suppose this, wow. No, it's not. Okay, suppose 1. Positive 1. Positive 1, they are not effect because positive 1 is invisible multiplier. So now the red one, que the transformer, is equal to blue. Perfect coincidence. However, if you multiply by 2, by 3, by 4, by 5, inside the parentheses, look at the effect. The effect, actually, the name of this effect is horizontal compress. maybe it's not too clear. So the name is confusing. But the important is not the names, it's the shape. Okay, what is the effect? Let me show you in the opposite direction. In the opposite direction, I restore again 1. Look, I want to put a fraction. I put 0.5, 0.6, 0.8. Look at the effect. Ooh, the effect is horizontal stretch. So somebody pull in the right direction, pull. However, in this is push in the left direction. Okay, the name is, I want to copy on the whiteboard now, everything. The thing I want to illustrate is only the modification and discussing a little bit the name. No? This is horizontal compress. This is horizontal stretch. Important. Si I change the sign, wow, is reflection. But another kind of reflection. Suppose -1, exactly -1. -1 is reflection, but reflection are about or across or with respect the y-axis. In this case, the y-axis behave like a mirror, and the new graphic is the red one, is the image of the basic function, que is the blue one. Do you see or not clear? Not super clear, right? Okay, now evacuate any question in the whiteboard. I want to go to the whiteboard again. Okay. Whiteboard, share. Do you see my whiteboard now or no? Yes or no?
Yes.
Okay. The second transformation in the order we study is horizontal shift. In the horizontal shift, actually, the modification, the transformation is inside the parentheses. It's important that you understand the differences between this action and this action. In this case, I adding or subtracting outside the parentheses. This is the reason that you affect the y value. In this case, no, you affect the x value. Okay, now, the transformation is, for example, suppose that we have again one more time our basic parabola x squared. I take this like example because it's easy to understand. Okay, suppose that this is y equal x squared as the basic. However, I want to do something. I want to do x minus 5 squared. And so this new parabola, the vertex, que now normally is in 0, 0, now it's changing to the 5. But in what direction? 1, 2, 3, 4, 5. Here, 5, 0. Why? How do you know that? Because when you evaluate at x equals 5, 5 minus 5 is 0. That's the reason that the y value is 0. Okay, so the motion is, when you see that the A number is negative, the motion is to the right. Completely opposite, in my opinion, no? To the common sense. However, when the A is positive, for example, another example, y equal x plus 2 squared. Again, you recognize a horizontal shift because I introduce a constant inside the parenthesis. Cool. However, it's positive. It's positive, it says to the left, to the left, to the left. And to the left is is suppose here 1, 2, -2. Now my new vertex of the parabola. So this parabola is x plus 2 squared, and this parabola I forgot is x minus 5 squared. And analyzing point by point, any point x comma y and the base, this is in the base. Now in the base is transformed in the new one in the transformed function like x minus a comma y. So the y value stays the same, but the a is subtraction, no addition like this. The subtraction. Bueno, subtraction no. Opposite sign to the transformer. Si a es 5 negative, entonces es double negative, negative become positive, the point is 5,0. Look at that. This idea is confusing. I understand it's confusing. Or no. Opinion.
It's very easy.
Okay.
I understand it perfectly. Thank you.
Okay. Emily, you say I understand. Who are you, miss? Your name?
My name is Annika.
Number 3 transformation is, what is the name? Well, the name is, well, a compound name is vertical. It's important, this vertical something, vertical. Okay, it's easy, Sophia. Okay, vertical, what? Vertical stretch. Or compress. Or reflection. Three action. Entonces this is, again, I have my basic function. But in this case, I multiply. No addition, subtraction anymore. No. It's a factor. You multiply by the number que I want to call B. But let me change. This is B. Much better change this to B. So A is the letter that we are using to the vertical shift. B is the letter that we're using to the horizontal shift. And C was a factor in the vertical stretch, compress or reflection. Suppose that we have the function f of x, the base, and now the action that I do is multiplication. Y, new y is equal to C times f of x. And who is C? It's the famous factor, factor C. Then we have 3 possibilities. If C is a number bigger than 1, is positive, and bigger than 1, 2, 3, 4, 5, 2.5. Entonces es obvio que we are doing vertical stretch. This is a stretch. This is a stretch. So basically my curve is not in the original shape. It's modification. The shape, how? Well, vertical stretch, no? One way to explain clear this. Suppose we have a picture, and this is one happy face, no? And you multiply this happy face by 2, like that. This new happy face is a little bit long, but vertical, because it's vertical stretch. Okay, you have multiplication, but multiplication only the y component. So the effect of the point is, suppose you have x comma y in the base, and you modification, pero multiplication by the factor c, and the x stays the same, doesn't change, but the y no, the y change, multiplied by cy. That's the effect. You see, multiply by 2, my new happy face is long, alone, pero es vertical. Ok, entonces to make maybe a zoom in, no es exactly this transformation, it's a combination of several transformation because zoom in, I need to stretch vertical and stretch horizontal, both. But okay. Now, entonces, if C is bigger than 1, it's a stretch, vertical stretch, vertical. We are talking about vertical. If C is a number in between 0 and 1, it's a fraction, 1/2, 0.5. Entonces, vertical, pero compress. Okay, so you multiply by 1/2, my happy face now is here. It's a half. Huh? I don't do very well, maybe. This distance is half of this. And this distance is twice this distance. And if C is -1, it's totally perfect reflection. About x-axis. Very clear. Finally, we continue theoretical part. We almost finished. Now horizontal. Horizontal stretch, similar name. Compress, similar name. And reflection. Pero another kind of reflection. With the factor, let me call D. The factor now I change the letter D. And we have the original basic function. Okay, f of x, y equal f of x. Let me try to write y equal f of x. But now the transformation that I am doing is different. I multiply by the inside the parentheses, and the effect is different. It's different because look, when you multiply by d and you multiply inside the parenthesis, and the basic point is x comma y, you transform it to you modify now the x, pero division by d, opposite operation, and the y stays the same. Therefore, if d is bigger than 1, similar to this, is horizontal, but in that case is compressed. Remember, in the example we see in Desmos, we apply this effect and the function is square root because it's more clear to see the effect. Square root function look like that, square root function. However, if you multiply by a number, for example, square root 2x, the effect look like that. So now the understanding of this is when you multiply by 2, we have a horizontal. Horizontal is, guys, in that direction. Vertical is in that direction. We compress because somebody push to the left. That's the effect. However, if D is in between 0 and 1 like that, let me write properly. It is in between 0 and 1. I don't know include 0 and 1 inside the interval because this is trivial. We have horizontal again, but in that case stretch. The effect is something like that. Suppose que I stretch. Suppose que I multiply square root 1/2 x The factor now is less than 1, and the curve is a similar shape, but is stretching horizontal in that direction. And if D is -1 equal -1 is the perfect reflection about y-axis. Entonces now, for example, let me try to do my best. Suppose the curve square root is in that direction, but it's a square root -x when the factor is negative. You see? You see?
Yes.
Okay. Now let's see example. I bring some example. Okay. The first 3 examples are easy. But the other example is a little bit complicated. Because it's, well, it's relatively complicated. Okay, don't worry too much for this. Look, let's see this example. Okay, I can erase the board. Remember, conclusion is we have four transformation. Vertical shift, horizontal shift, vertical stretch, compress, and reflection, and horizontal, horizontal, sorry, stretch, compress, and reflection. Okay, look at the example number 1, que es a piece of cake, super easy. Example 1, and you help me a little bit, and after we see the effect in Desmos. Example 1, suppose we have a function que es square root x plus 6 minus 5. Okay. Entonces now, what is the typical question here? The typical question is, using transformations, try to do the graph of the new function. No? So the first thing you should do is recognize what family belong this function. So what is in other words, what is the basic function associated with this? What is the mother? What is the original basic function? What is the basic function? So I see in the library of the function, what is the formula that looks like similar to this? What do you think? Come on, help me. No idea.
Vertical shift.
No. My question is, no transformation. Yeah. Maybe you're right, but no, okay. My question is easier. My question is, in the collection of the function that we know in college algebra, what is the basic function in which this example belongs to this family? Ese parábola, ese square function, ese reciprocal function, absolute value function. No, the only thing you should do is looking the expression, no? And the expression is a square root. This is the basic. Do you understand the idea? It's super straightforward. Yes or no? Come on, guy. Do you follow me?
Yes.
I don't know. The complicated part is the part you want. You see transformation. What transformation you see? You see one transformation or two transformations?
Only one.
Only one. No. Look at the difference. You have +6 and -5.
There's 2 transformations.
Exactly. Es two transformations. Ahora, according to the order of operations, the first transformation, transformation number 1, is +6, right? According to the order, and you need to proceed according to the order of operation. Remember, the radical behave like a grouping symbol, no? Like a parenthesis or bracket, whatever. Entonces, transformation 1. Entonces, now, the transformation 1 is a new function que es square root x plus 6. And x plus 6, you interpretate like it's f of x plus 6. Makes sense, right? It's inside the parenthesis, not outside the parenthesis. Right? And the transformation 2, que es -5, would be f of x minus 5. Do you see the difference between this 6 and this 5? This 6 is inside the parentheses and the function notation, and this 5 is outside the parentheses and the function notation. Yes or no?
Yes.
Cool.
Yes.
Now,
Mm.
what is the name of the first transformation? What is the name of the first transformation? O sea, that one, +6. ¿Es vertical shift o es horizontal shift?
Horizontal shift.
Ajá, ¿en what direction?
That's going to the right.
To the left.
Oh.
Oh, when it's inside the parenthesis, I understand. It's confusing. When it's inside the parenthesis, it's completely opposite. Remember? Okay. Look at that. Look at that. Guy, focusing. This is hard, I know. Sorry. This is the basic function. Square root. Look like that. Is you take this. Now, we apply the transformation number 1, que is horizontal shift 6 unit to the left. So at this point, que normally is 0,0, now is located here now. Okay, and this is the graph of the square root x plus 6. Do you follow me? Do you follow me?
Yes.
Okay.
Yes. Yes.
Yes.
And this was horizontal shift 6 units to the left. Okay, cool. Now I feel no. Are now -5. What is -5? What kind of transformation it is? -5. It's subtracting 5, pero outside the parenthesis. Y si es outside the parenthesis, obviously the transformation is not horizontal, it's vertical, right?
Yes,
Yes.
it's vertical.
Es vertical. Vertical shift, no? Vertical shift?
Yes.
Yes.
Okay. Vertical shift. In what direction?
Down.
Down. It's 5 units down. Okay, so let me try to follow in the track of that point. That point original was 0, 0. That point is now -6,0. So you move to the left. And finally, when you subtracting 5, this point is moving here, and the point is -6, -5. And our final graphic look like that. It corresponds with this. Make sense? Make sense?
Yes.
Okay. After I want to show you in Desmos. Let me try to do one more in the whiteboard. After I went to switching to the Desmos to see more clear the transformation. Example 2. Example 2 is another function que es minus x minus 5 square plus 3. Okay, let me copy more clear. Minus one negative sign here, x minus 5 a square plus 3. Okay, my first question always is which are the basic function? Okay, you associate with this. What the mother can generate this? This is a member of the one family that belong to the one function that you very well know inside the library. What function is the mother? What function is the basic? What function is the original without transformation?
Quadratic.
Exactly, quadratic. Okay, you see the operation, look, quadratic, these two, give me a clue, okay, these two. Likewise, this square symbol, radical symbol is this, is the clue. And now, how many transformations you can see? How many transformations? Be careful, be careful. Remember, you analyze according to the order of operations. Order of operation means that when you plug in one number, you replace x for one number, you subtracting 5, after you square, after you change the sign because you multiply by -1, and finally plus 3. This is the order of operation. And how many transformations you can see? How many?
3.
3. Very well. 1, 2, 3. Transformation 1, transformation 2, and transformation 3. What is the first one? Can you see?
The one inside the parentheses.
X minus
Oh.
5. X minus 5. So you are doing this transformation, miss. Que es x minus 5 squared. What we are doing? What we are doing? Es the vertical shift, horizontal shift. Because I know very well that when you addition subtraction is shift, but inside the parenthesis horizontal and outside the parenthesis vertical, no? So this is what kind? I need to categorize, use a name. What is the name of the transformation?
Horizontal.
Exactly. Horizontal shift. In what direction?
Right.
To the right. How many units?
5.
Exactly. To the right. Everyone follow me, guys? Because it's negative, no? When it's negative, oh, it's opposite operation. What is the second transformation, please? What is the second?
Oh, the multiplication one.
Exactly. Multiply by -1. And when you multiply by -1, what is the effect that we are doing? Huh?
It's a reflection.
Exactly. It's a reflection. It's a reflection across the x-axis or the y-axis.
With the x-axis.
The x-axis. Very well. Wow, strong. And finally, plus 3. Outside the parentheses. Entonces, what is that?
Vertical stretch.
Exactly. Vertical, no. Vertical shift. Stretch.
Yes, sorry.
No, it's okay. Maybe you are clear in the concept, but you confuse the name, no? But the name is important because it's no equal Maria que Mariana, right? But the name is important. It's vertical shift, 3 unit. In what direction? In what direction? In what direction?
Up.
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 Because it's positive. Cool. Okay, so now let me try to do in the piece of paper the transformation one by one, and you see the effect. No? Suppose at the beginning I have my famous quadratic function. This is x squared without transformation. The first transformation that I am doing transformation number one was horizontal shift 5 units to the right. Okay. So now this is 0. Now we have 0, 1, 2, 3, 4, 5. That my new parabola is now the same shape because the only thing I am doing is moving shift to the right. 5 units. This is the equation x minus 5 x squared. Correct? I promise you see decimal right now. Everyone follow me?
Yes.
Cool. Now reflection. And the second transformation, the only thing I am doing now is flip it and 5. Now it's down. It's down. This is the equation. This is y equal. It's the y equal minus x minus 5 squared. Do you see clear the effect of the multiplication by -1 affect the y value? That is the same. Suppose that 1 point here is 6,1, no? Because 6 minus 5 is 1, 1. So now that another point here is 6, -1. That the x value stays the same, but the y value change the sign because you are multiplied by -1. Okay? And 0 no, because it's 5,0. 5,00 have no sign. 0 multiplied by -1 is 0. Entonces 5,0 stay. Okay, finally, 3 unit up. 3 unit up means okay, any parabola, any new parabola. Remember, the transformation is sequentially. We are doing transformation 1. We are doing transformation 2. Now we are doing transformation 3. But not the original. No. Sequentially, you continue working with the same. It's 3 unit up at any point by point. For example, that famous point actually 5,0 would be 5,3 because you adding plus 3 any point on the parabola. It's a 1, 2, 3. So this point is 5,3 and the parabola continue open down. Makes sense? And this is the final answer. This graphic corresponding with the original after the 3 transformation. Do you understand or no? Confusing or no? Question. Let's move on to decimal to see more clear. I want to repeat again the idea, but with animation to understand more clear. Okay, let me try to find the script of this, get the example of transformation. Okay, let me share the screen with you. Okay, example of transformation. And we come back to the first example. Okay, no, fine. Example 1. Example 1. Do you see the decimals or no?
Yes.
Okay, I try to do every graph together. If you want, delete this and delete this. This is the original square root function. The first transformation was 6 unit, the horizontal shift, 6 unit to the left because it's positive, and positive to the left. And finally, 5 down. And the final answer after all transformations is the green curve. We start from this, and step by step, transformation by transformation, we are doing this. It's more clear now? It's more clear now? It's more clear now?
Yes.
Answer yes. Okay. Let me go to the second example. The second example is this. Uy, 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 no, 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 no. We start at the beginning with the basic parabola. This is the basic parabola. And transformation number one was a horizontal shift 5 units to the right. Boom! Look at that. After that, reflection. Look at that. Boom. And finally, plus 3 can represent the vertical shift 3 units up. Boom. And this is my final answer. So see, I can delete, for example, this. The thing is, okay, doing 3 transformation, we go from the origin against this to the final answer against this. Super cool. Everyone follow me?
Yes.
Emily. Okay. 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 Let's move into example 3. Example 3 is the cubic function. So the original function is, okay, the original function is this. Look, the original, no, the given. So it's given that function. Yeah, I want to investigate from scratch, so from the original basic. It's obvious, no? The basic function in this case is the cubic function, no? By the way, the cubic function look like that. Look, cubic. Oh, no, 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 everything. Cubic function is, this is the block. It's a cubic function. This is a cubic function. So how many transformations and which transformation you can see? Please help me. X minus 1 inside the parenthesis, no? What is that? What is that? What is that? Come on, guys, what is that?
Horizontal shift.
Horizontal shift. In what direction?
Let's go to the right.
To the right, because it's negative. And negative to the right. Okay, so now my new curve look like that. Look, boy, do you see the idea? The original cubic function is the black one. However, when you introduce inside the parenthesis minus 1, it's horizontal shift 1 unit to the right. And plus 7, finally, plus 7 is an also shift, but what kind of shift? What kind?
Vertical shift.
Vertical shift? Yeah. And what direction? 7 unit up. 7 unit up. Boom. Too high. Okay, basically, we transform it from the black one, que is the basic, to the blue one, que is the, okay. You understand very well this or not? Fortunately, or unfortunately, some example is not trivial. Suppose this example 4. I want to copy. Example 4 is, I want to copy in the whiteboard. Don't worry for this. Pi equal square root 5 minus 6. Okay, let me try. So I want to explain in the whiteboard, and after I come back to the decimal to see our prediction. No? Okay, share whiteboard. There you go. You let me know if you see whiteboard. You see?
Yes.
Okay. Okay, this is example 3 ID and decimals, no? Okay, everyone understand because it's easy. Example 4, no, it's complicated. It's complicated because it's not clear to see the transformation. Look, The function is f of x equal square root 5 minus x. Okay. The complicated part is to see what is the transformation. Do you have some idea? Come on, try. You try. Suppose you are doing wrong. No problem. So, number one question is, what is this example is a member of the what family of the function? So what is the basic function?
Radical.
Square root, yes, radical. And this is a member of the family whose the mother is a square root function. Square root function. Good. Now, do you see inside 5? And do you see inside minus x? Wow, what the hell? Is reflection or is horizontal shift? Vertical shift, no. Because to be vertical shift is a phi is outside the rack. So is, what do you think? No idea? So this is the kind of problem. It's super interesting to put in the text. Because the example 1, 2, and 3 that we were doing before, the transformation is clear. It's obvious, it's elementary, you see. Not necessarily algebra. But sometimes happen, yes, okay, you need to apply some algebra to visualize this. Okay, so the algebra, so you intuition say something, no? Is they are reflection or no? What do you think? Remember, reflection is when you put a minus here, automatic reflection. Yes or no? And you see a minus here. Yes or no? So my intuition say, well, okay. They are maybe reflection. But see, I put here, forget about the minus sign. Suppose forget about the minus sign. See, I put here plus 5. Oh, I understand very well is the horizontal shift 5 unit to the left. Clear? Clear or no?
Yes.
However, this is the combination of both, and we are way. So now that means that when you face this kind of problem, get classical, you need to apply some algebra inside the radical to understand more clear, so it's not ready to visualize the transformation. But it's no big deal. Look, see, I factorization minus 1. This minus I put outside. Then you have x minus 5. Let me try to understand, see, this expression is equivalent or no to the original. You apply distributive property is minus x and minus plus. So you interchange f5 minus x. Clear, right? Is clear or no? Yes. Okay. So now, now we are ready to understand the transformation. What transformation you? How many transformation? Well, there are 2 transformations. Transformation 1 and transformation 2, no? It's very clear now, Anika. Entonces, Anika, say what is the transformation that you see? Very clear. What transformation do you see? What transformation you see? Come on. What transformation you see? It's very clear. But what transformation? Come on. No necessary, Anika. Another participation. They're free. Free for everyone. Okay, look. This is f of x equal radical x. However, the new f of x is minus x minus 5.
Is it reflection?
It's a reflection, very well. It's a reflection, very well. How do you know the reflection? Because this negative indicates reflection. Reflection about what? What axis? What axis?
The
Huh?
x-axis? Is it the x-axis?
Oh,
No, sorry, y-axis.
okay. Let me take advantage the moment to understand that part. We have two kinds of reflection. We have minus f of x, and we have f of x minus x. This reflection is x-axis, when it's outside, the minus is outside, and when it's inside, it's y-axis. It's obvious que in our example, the minus is inside the parenthesis, entonces y-axis. Clear?
Yes. Thank you.
One more reflection, one more transformation, you see. So this minus indicate us que reflection. One more transformation. You see. No idea. Nobody. What is that, guys?
Horizontal shift.
Horizontal shift. Very well. In what direction? To the what?
To the right.
To the right. Super. Okay, in the original, it's very confusing to see that. Therefore, there are some problems in which you need to apply some algebra first to understand more clear the transformation. Let me try to do in the whiteboard. Okay, we start for the original square root function. The original square root function look like that. First of all, we are doing reflection. See, we are doing reflection. Reflection is like that. This is a square root minus x. Cool. And now 5 unit you say to the right, 5 unit, I forgot to say that. So at this point is 0, 0, 0, now is 5. This point is 5, 0. And our final graph is square root 5 minus x. Okay, so not always is straightforward to see. You need to apply some algebra to understand this. Okay, I have another example, confusing example. Okay, another example 5. Any question? Do you follow me or no? Totally lost or clear? Of course, you need to practice. Hello. And the practice, as always, you are doing the homework online. No? Remember, I designed the course. In Alex, you have homework and you have tests. No? You are doing the homework by yourself. You have questions, you email me. You send me the screenshot of the problem that you cannot solve. What is the reason that you send me the screenshot? Because when any guy open Alex, you see different example. It's the same topic, the same objective, but different number. So some students say, Professor, do for me number 5. No, number 5 and my Alex is different to you Alex. So you send me the screenshot. I solving the problem. I try to explain clear in the whiteboard, no? But I make another screenshot and I send to you. Fine. And so you don't understand, well, we can communicate. We agree one moment to open Skype extra. Uh-huh. Or, so you understand, que es the majority of the case, cool. Uh-huh. This is the way. Remember, any chapter, we have 4 chapters throughout the semester, contain for each chapter 1 test online in Alex. The extra credit is the homework. So you're doing the homework, you are doing well. And well means 80% score in the homeworks, in any homeworks. You get 10 extra points. And the written test, I will send soon, no, Wednesday. The test number 2. You are doing in the piece of paper, you scan in your scanner or take a picture, either way, I don't care. You send me by email. But I want not only the answer, I want the word in detail. It's written test. I want to see your skill in algebra. You put the final answer, 0, 0. And some students that don't know anything, write nonsense thing that I don't understand. Si I don't understand, it's 0. When I explain clear. Si I explain confusing, you say I have a question. So I have a question is 0. So some people say, no, but what is the reason you give me 0? 0 because I understand, no? You have opportunity maybe to send me a right. Okay. Okay, entonces now example 5. Okay, this speech is clear. I explained the first day. Basically is for the students que are clueless. Okay? You remember, you stay with me when the class is over. No? Okay, example 5 is f of x is equal x squared minus 4x plus 5. Wow, what the hell? Let me write clear. Minus 4 x plus 5. Okay, entonces, again, the same question. What is the basic function associated with this?
Quadratic.
Exactly, very well. This is a member of the family in which that function is the mother, is the basic, is the original, is the principal, is the main. But we see transformation. But the easy to see transformation is very, 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 very complicated. Do you see something or no? No? Horizontal shift? No, because I know the format for the vertical shift is something like that, plus something. But horizontal shift is maybe minus something. But this is not clear because it's minus 4. What is the reason that I have no minus 4 here, only minus 4 here? The problem is that sometimes, again, you need to apply some algebra to understand more clear this. The algebra is completely square. Are you familiar with the completed square? So suppose I replace f of x for y. And now I know that I need to complete the square. So I put y alone is equal to x squared minus 4x plus a box. In the box, I have the magic number that completed square plus 5. In order to doesn't affect my equation, you put this box here and you put this box here. Because I want to introduce artificial number here, right? So now, so you put artificial number here. I need to put the artificial number here because, you know, I have different equation. So to keep the equilibrium of the equation, I complete the square, cool. No, I understand. However, I put the artificial number here and the same number in the other side. What is the magic number in that case? Magic number que allow me to complete the square.
4.
4, so look at 4, right? Everyone Understand get 4, right? We're discussing in detail this idea. You put 4 here and you put 4 here. You are the best. I put 4 here and another 4 here. Okay, entonces y plus 4, change the order. So now it's perfect square trinomial, and the factorization is x minus 2 squared. That's fine. Finally, solve for y, so I present explicit form. The y is isolated. X minus 2 squared plus 5 minus 4. Now 5 minus 4 is 1. So now my function f of x is x minus 2 squared plus 1. Wow. Now you see clear like a water the transformation. How many transformations and which transformation you see? How many? How many? How many? 2 transformation, 3 transformation, 4 transformation, 20 transformation. How many?
2.
2. And which is the transformation? Transformation 1, transformation 2. Remember, we're proceeding according to the order of operation. And the order of the operation, when you plug in one number here, you are doing the operation inside the parentheses. No, so we try to investigate what's going on when you are doing this operation. And this is what? Horizontal shift. In what direction? To the right or to the left? To the what? That you say que horizontal
To the
shift?
right.
To the right. To the right. Right. To the right. Cool. And what about plus 1? And what about plus 1 outside? And what about plus 1? And what about plus 1? Plus 1 is vertical shift up, vertical shift up. 1 unit. Super cool. You understand very well. Let's see this example and this example, both number 4 and number 5 in decimals. And you see animation.
Professor, I have a question.
Go ahead.
I got confused when we are trying to solve the equation to see clearly the transformations. What is the difference if we doesn't use the factorization instead of the, if we use the factorization instead of the completing a square?
Well, because completing square means, so you're doing by factorization, you have the factor 2 and you don't see clear the transformation. Remember, the transformation is your addition or subtraction inside the parenthesis, addition or subtraction outside the parenthesis, multiplication whole thing by one factor, or multiplication whole thing inside it. So now, in that case, you are doing the factorization, it's not clear. However, here is clear because we have only one factor, not 2. And you know that this idea is minus 2. It's horizontal shift. And this is 1. Do you see or no?
Yes.
And do you understand very well the process of the completed square?
Yes.
This is important. So basically, it's completed square. It's the best way. Let me try in decimals. And I want to explain everything again. Okay, share this. This is a complicated part. Manipulate the screen. Okay. Do you see decimals now? On. Do you see?
Yes.
Remember the example 4. In the example 4, we have this example, this expression is given like that. However, for me it's confusing. I don't understand anything. However, I recognize Okay, this is belong to the family of the square root function. Okay, so now, so you are doing reflection. Look at that reflection. Reflection across the y-axis. This is typical reflection. And finally, this purple color curve, I'm moving 5 units to the right, like that. Bam, and green color. And this is equivalent algebraically and geometrically to the given is this. Look at that. Okay, blue. Look, the green and the blue is the same. Do you see? Do you see? Do you see?
Yes.
Excellent. Now example 5. Example 5 is this. Is this expression? I cannot see. But I detect immediately it belongs to the family of the parabola. Okay. Now, using completed the square technique, I discover this expression and this expression are algebraically equivalent. This is the same thing. Therefore, step by step, I am doing horizontal shift to unit to the right. Okay, and after I go vertical shift 1 unit up. Boom. Okay, let me write this. And this I should be equivalent to the graph of this. Oh, look, the black color and the blue color is the same curve. That's mean clear that they are absolutely equivalent, 100% geometrically and algebraically. Any question? No? No? Okay. So I want to summarize everything, condensing, conclusion. To make a conclusion, okay, you don't see, you focus in the picture, not in the algebra. Beside this, the picture. Look, suppose I have the function. The function in this case is not the typical function that we study in the library. No, it's a segment line. How do you know it's a function? Because so you apply the vertical line test, touching only one point. So this is a function. It's a segment, but it's a function. Suppose now I apply the Fourier transformation and you see the effect, and we compare the effect, the motion, the animation, and the name. Look, suppose I move A. A is vertical shift. Look. Oh, sorry. Is this. Okay. Do you see vertical shift when the A is positive and when the A is negative? Clear?
Yes.
Now I see horizontal. Horizontal is B. Is this. Horizontal shift. Oh. When the B is positive, to the left. When the B is negative, to the right. Clear? Clear?
Yes.
Okay. Now, let's see now multiplication by a factor outside the parenthesis and inside the parenthesis. Let's outside and the factor is bigger than 1. Look at the effect. The effect, in my opinion, is this is vertical stretch. Yes or no? Vertical stretch. You multiply by 1.9, you multiply by 2, my segment. Okay, somebody pull over and modify the shape. It's different shape. It's no shift. Shift is only motion, translation. No. This is modification shape. This is stretch. Makes sense que es stretch or no? However, if you come back at the beginning, you put the factor 1, no transformation. Si the factor is less than 1, it's a fraction, it's a decimal. Oh. This is compress. Vertical compress. Make sense? If C is -1, if C is -1, is perfect reflection. Reflection about x-axis. Super clear or super confused?
It's clear.
Now the last case, in my opinion, the most complicated to understand is when you multiply by the factor but inside the parenthesis. Let's see, pay attention. When you multiply inside the parenthesis and the factor is greater than 1, what is the name of this effect? This is horizontal press. Do you see? However, when the factor is less than 1, let me restore 1 again. No transformation. When the factor is less than 1, it's fraction. Oh, what is the name of this effect? The name is horizontal stretch. Now it's more clear? No, they are not all the functions. You see the picture clear. I select this segment because you see the effect more clear. Now, suppose that D is negative, -1, -1, -1, for example, to make a perfect reflection, -1, -1, -1. You see that the new segment, the purple color, now is a perfect reflection of the original segment, but a symmetry or reflection across or about or with respect the wax. Super clear. Super clear or super confused?
Clear.
Okay. Okay, we dedicate the rest of the time, que 10 minutes, to try to explain a new thing about the functions. So we are doing transformation. So that when you have transformation, we generate from one basic function a family. However, another transformation of the function you need to know very well is the piecewise function. Piecewise function. And piecewise functions is a function that is generated in different pieces and these pieces you need to be familiar with the notation of this. Suppose this, one example. Suppose the function f of x gets defined using different pieces and different intervals. You open the big curly bracket like that, and you copy here the expression que es x. If, and you copy the condition. This expression is valid for the x less than -1. We have another piece que es x squared plus 1 if x is in between, include the endpoint -1 and +1. And phi, que es a constant function, is, if x is greater than 1. Okay, suppose it's given in the test like that. Now, interpretation is, what is that? Well, the interpretation of this is, look, this is my famous Orion number line. This is my famous Orion number line. This is infinity, positive. This is infinity, negative. I take 0 in the middle, que es a reference.
Professor,
However,
We are still seeing decimals.
Sorry. Thank you so much. Okay, piecewise function. Now, do you see it?
Yes.
Okay, cool. Thank you. Okay, entonces -1 y en +1. La piecewise function is the topic que we start today. We continue next time. Piecewise function. Okay, now you need to be familiar with this notation and understand what means that. The one function is given and it's given by 3 pieces, 1, 2, and 3. And each pieces is defined in a specific interval. They correspond each other. So to understand the interpretation of this, okay, I copy my famous or real number line. The I splits in different intervals. For example, this interval, que es less than 1, is this interval. So the function is equal y equal x. Any point that you evaluate here, bam, and lie, in this interval, we're using this expression. Let me use another color, maybe green. The interval in between -1 and 1, que es this interval. We're using this function. Is y equal x squared plus 1. That one. And the interval after that, let me using another color, maybe red color, that part. Is this interval greater than 1? We use 5. We use 5, que es a constant function y equal 5. Okay, to understand much better, I propose you evaluate different points. Evaluate in -2. This is a typical example in the test guide. Evaluate in -1. Evaluate in 0. Evaluate in 1. Evaluate in 2. And evaluate in 3. Okay, so now this is value inside the parenthesis. Is value of the x value domain. -2 here. -2. Obviously, okay. Obviously, they are a process of selection. Don't interrupt me, please. This is a process of selection in which you select this expression because -2 lie in the blue interval que corresponde with this function, and you evaluate. You copy x and you plug in x equal -2, and the answer is just -2. It's a coincidence. Now, this is confusing. -1, here, -1, this is -1, lie here. Exactly in the boundary between blue and green, but belong to the green because this equal sign is here and no equal sign here. No. You using the expression x squared plus 1, and you evaluate at x equal -1. Entonces, -1 squared plus 1, ¿qué es 2? -1 squared positive 1, y 1 plus 1 is 2. Do you follow me? Now 0 again belong to the green interval. Therefore, the process of selection, you select the piece que corresponde with the green interval. Okay, Sofía. Entonces now one more time you select x squared plus 1, pero now you add 0. 0 squared plus 1 es obvio que es 1. -1 or positive 1, sorry. Belong again to the green. Remember the endpoint belong to the green. Suppose you are doing in this notation, bracket, bracket, belong to the green, both endpoint, -1. Not necessarily it's always the same. This is just example. There are another example that I change something. So in one, again, we select the same expression, but you evaluate at x equal 1. Now this bar indicates such that evaluate 1. So you replace 1 here, a 1 squared plus 1, a 1 plus 1 is 2. Again, is 2. And now 2 and 3, well, 2 and 3 belong to the red interval is the expression of phi, and phi do not depending of x, it's just phi. No substitution for any because it's a constant function, and constant function do not depending of x. We have no x here, therefore it's constant, it's phi. The y value is always 5, 5, 5, 5, 5. Okay, we continue next time doing this. Stay the student guy, select the rest. You can leave, guy. Thank you so much for your attention. It's a pleasure work with you. Bye-bye.
Bye, Professor.
Thank you.
I'll be right back in one second. Entonces now, basically, the student I need to talking is Yamori Eliscar. Are you there? Cool. Janelle Williams. Janelle, excellent. And Sofia Adolfi.
Yes,
Sophia?
I'm here.
Okay. Well, I try to explain. I know the majority of the students very well know because they are a student of continuation, and the last semester, que es 8 week, was the similar policy. Now, do you understand now that we have 4 chapters? Each chapter contains 2 tests. One test is reading test and paper. Okay, same in your moment. And you need to solving in the piece of paper, scan with the answer and solutions and send me back. Yeah, great. Yeah, post it in Canvas. And the second is online. Online is in Alex. So you need to be honest with me now. You visit Alex or no? Or not yet? Remember, Alex, you need to buy some money. Using financial aid or your own money, either way. You create an account using credential, and in the syllabus, I provide the class code. The class code allow you get inside our class. And it's waiting for you, the test and the homework. Remember, the homework is extra credit, 10 points, and the test no, it's mandatory. Okay, those are for each chapter. Any question that you have? Okay, suppose all of you receive the test on paper, so the reading test, or not yet?
Yes, I received it.
Sofía, Janelle, and another student que Amaury. You receive, Mr. Amaury? Yamauri. Yes. Okay. So now we agree one comfortable way. Not necessarily you tell me now. You email me, you see. This is was due, but I extending a little bit to today. Si today is not good for you, you let me know by email. Don't ignore me, because you ignore me, I believe that you don't care. If you don't care, I drop you as soon as possible, right? Now, I suppose that some of you need extension to finish the test number 1 online. But do fast, because the test number 2 is running now. A ver, Sofía, you need extra extension? Sofía, Adolphe? Yeah, professor, email about my, okay. Bueno, entonces, what is the, okay, entonces I create extension for you, specifically for you, to the same day of the test 2. Es clear que es, I suppose que es Friday. I suppose que es Friday is 11, no? Friday is 11. Let me see in the calendar. Friday is 11. Wait a second. Oh yes, it's 11. Friday is 11. Bueno, okay. Entonces so far, my idea today is the second test is due 11 November, no? 11. Entonces I create for you 3 students extension for November 11, test number 1 online. So you have no time to the test number 2, so I create another extension, but I definitely it's the last extension. And you need to go to the same velocity of the students, okay? Okay. The idea is clear? Is clear, Sofia? Is clear, Williams?
Thank you.
No problem. My pleasure anytime. You communicate with me. Communication is extremely important in this kind of class. In this kind of class, que es online, but it's not online. Because you need to go directly to, but you need to attend this, to the lectures, to follow in the procedure, because we change due day, maybe, depending the dynamic of the class. Okay, guys, thank you so much. I gotta go. Any other question? No? Thank you. No problem. Remember, I am your friend, not your enemy. I am friend. Bye-bye.